In this video, we will learn about VSWR, reflection coefficient, and return loss in a very simple way. What happens when a transmission line is not matched? When a transmission line is connected to a load that does not match the line's characteristic impedance, some of the signal gets reflected back. This creates a standing wave on the line. What is VSWR? VSWR means voltage standing wave ratio. It compares the maximum voltage on the line to the minimum voltage on the line. The formula is VSWR equals Emax divided by E-minute, where Emax is a maximum voltage and E-minute is a minimum voltage. Another way to say this is VSWR equals incident voltage plus reflected voltage divided by incident voltage minus reflected voltage. If there is no reflection, the VSWR becomes 1, which means a perfect match. What is a reflection coefficient? The reflection coefficient is written as a Greek letter rho. It tells us how much of the signal is reflected back. The formula is rho equals load impedance minus line impedance divided by load impedance plus line impedance. There is also a relationship between VSWR and rho. Rho equals VSWR minus 1 divided by VSWR plus 1. And the reverse formula, VSWR equals 1 plus rho divided by 1 minus rho. A perfect match means rho equals 0. What is return loss? Return loss tells us how much power is not reflected, and we express it in decibels. The formula is return loss equals minus 20 log of rho. Higher return loss means a better match. For example, 20 dB or 30 dB return loss is very good. Summary: mismatch creates reflected waves. Reflected waves form standing waves, measured using VSWR. VSWR 1 means perfect matching. Reflection coefficient tells how much is reflected. Return loss in decibels tells how good the matching is. First, return loss. Simple explanation. Return loss tells us how much of the incident power is reflected back from the load. It is always a positive value. If return loss is high, it means very little power is reflected. So higher return loss equals better performance. Example: if the return loss is 10 dB, it means only 1/10 of the incident power is reflected. Second, mismatch loss. Simple explanation. Mismatch loss tells us how much transmitted power is lost because of reflection. The formula is mismatch loss equals minus 10 log of open bracket 1 minus rho squared close bracket, where rho is a reflection coefficient. Example for better understanding. For an antenna with a VSWR of 2 is to 1, the reflection coefficient is 0.333. The mismatch loss is 0.51 dB, and the return loss is 9.54 dB. Third, explaining the table in easy words. The table shows 5 things for different VSWR values. VSWR, return loss in dB, percentage power loss and percentage voltage loss, reflection coefficient, mismatch loss in dB. Let's understand the table in simple spoken form. VSWR equals 1. Return loss, infinity, meaning perfect match. No power loss. Reflection coefficient, 0. Mismatch loss, 0. VSWR equals 1.25. Return loss, 19.1 dB. Power loss, 1.2%. Voltage loss, 11.1%. Reflection coefficient, 0.111. Mismatch loss, 0.054 dB. VSWR equals 1.5. Return loss, 14 dB. Power loss, 4%. Voltage loss, 20%. Reflection coefficient, 0.2. Mismatch loss, 0.177 dB. VSWR equals 2. Return loss, 9.5 dB. Power loss, 11.1%. Voltage loss, 33%. Reflection coefficient, 0.333. Mismatch loss, 0.512 dB. VSWR equals 3. Return loss, 6 dB. Power loss, 25%. Voltage loss, 50%. Reflection coefficient, 0.5. Mismatch loss, 1.25 dB. VSWR equals 5. Return loss, 3.5 dB. Power loss, 36%. Voltage loss, 60%. Reflection coefficient, 0.666. Mismatch loss, 2.8 dB. VSWR equals 10. Return loss, 1.7 dB. Power loss, 50%. Voltage loss, 70%. Reflection coefficient, 0.9. Mismatch loss, 4.4 dB. Conclusion: as VSWR increases, return loss decreases. More power is reflected. Reflection coefficient increases. Mismatch loss becomes higher. System efficiency becomes worse. A low VSWR is always good. High return loss is also good. And low mismatch loss means better power transfer. Thanks, and meet you in next video.